We're live now. Hopefully y'all can hear me this week. Yeah. Rosby. Day 6, I think we're on. So if you're just tuning in for the first time on this stream, it's nice to meet you. My name's James, the Agent Ultra, and you're hacking on Haskell, learning new things. I'm starting with a little side project here, trying to implement a key value database from scratch in Haskell. I like to have little side projects sometimes just to try things out that I haven't really done before and keep learning. And if you're, a regular, welcome back. Thanks for watching and coming back again this week. So, big news. What's up, Wizard Stick? I got my camera back, so you can see me again. And that's a good thing, maybe. And I've managed to port over some of the development environment into WSL2. So on Windows, that's kind of like it's Windows subsystem for Linux or something. Basically running a Linux VM inside Windows with some pretty good integration. Oh, nice to meet you. Yeah, I hang out on Reddit sometimes and check out the Haskell Reddit. So if you're a fellow Redditor and you wanna hook up later and talk about what you see on the stream, then I'm on there. I'm also on the functional programming Slack and the Zulip functional programming Zulip as well. So we can chat there as well as on the stream. Hey man, how's it going? Nice to see you. Nice to hear from you. Yeah. So yeah, I got half the development environment moved over to WSL2. This is pretty dope because now I can actually it compiles really fast. Faster than it does on native Linux. Or sorry, on native Windows. I don't know why that is. So I'm just going to compile that now while we're talking. It looks like it maybe I've already done that. See, that's how fast it is. It's ridiculous. So this is great because now we can build in Linux and we can run in Linux. And I can finally show you that line buffering does work on a Unix like operating system. If we just run Rosby now, we got it there, and bring it up, then C. So we got the connection notice and the logs there. Type in a bunch of stuff and it just gets echoed back out to me. So that's pretty good. Next, I think I'm gonna have to port more of the development environment over because we want to be able to run like our HLint scripts and get all the rest of our development environment set up. But I'm still running Emacs natively from Windows. I haven't built GHC IDE, rebuilt it yet in the Linux environment, so we'll get on that. But this is good enough for now. So yeah, I'm pretty stoked about that. You can notice that I think when we echo at this line here, I kind of expect it to be in the logs, which it isn't, so it's kind of a bug. We'll have to fix at some point. And then I guess we'll get started reviewing what we did last week. So last week we started putting together the parser, as you may or may not recall. I do a little bit of Haskell. I don't really normally do it on Windows. I mostly do Haskell on Windows because it's just the easiest for my streaming setup. And technology in 2020 is failing me. My laptop broke, my nice ThinkPad. And my kids destroyed my TV. They knocked it over by accident. Nobody got hurt, thankfully. Oh, and then, of course, my camera died a couple weeks ago. So, but it's been a learning experience. We've learned some things about Windows and Haskell. We've learned that while Haskell is, yes, a production-ready language, maybe not so much if you're doing socket programming on Windows until the new version comes out. That's going to be in GHC 8.12, from what I understand from some of the core authors there. And it sounds like they've merged that in. There's going to be a new I/O scheduler coming up in GHC that's going to have better native Windows support. So that is going to be awesome for everyone. More users of Haskell, the better. Windows users shouldn't be left behind. It's actually turning into a pretty decent little platform. Like, you know, I've been kind of a Linux/Mac OS snob for years, and I don't think there really is a reason to be snobby about Windows these days. Like any technology. Anyway. So yeah, last week we worked on the parser. We're talking protocols right now. And we borrowed heavily from Redis's serialization format, known as RESP. The serialization format there, I think, is pretty nice. So let's just review that quickly. So basically we have here our prim types. So the serialization format on the wire is pretty simple. We have strings, numbers, and arrays of those things, given by the definition here. And maybe we'll add a few more as we need them. But I like this because it's sized. So we have the string of some integer length and byte string. And as we parse these things, like in our string parser, we check first the number that we parse. And if there is a number, we only take that many bytes from the stream. I'm a little bit slightly concerned about this, and I don't know if I should be yet. I'm just reviewing this because what if the user puts in like a fairly large integer there, and we have certain limits on the size of, say, keys in the database? I think that's pretty reasonable to have a limit on the size of the key. This level of the protocol, this layer, doesn't really know about those things yet, so I'm not really sure if it's going to be a problem or we should concern ourselves with that. But I'm also kind of not concerned a little bit, because if we keep this part of the code pretty lazy, we're only going to consume parts of this stuff one at a time, and so if we get, say, something that's supposed to be a key and it's too long, then we won't parse the rest of the stream. We can abort still early, even at that layer of the code. That's my intuition anyway. If you're a super experienced Haskeller and you can see the train wreck coming, feel free to discuss laziness and parsers in the chat. Yeah, so the IntelliSense is coming from GHC IDE, which just had 0.8 or 0.2.1 or something like that released. So it's pretty recent. They are starting to put out static binaries now. And if you're a VS Code user, the bundled VS Code plugin for Haskell will automatically download the static binary for your project, which is pretty cool. Oh, don't worry about space leaks. Trust me, there's space leaks. There's way more space leaks in C++ code. But we'll find space leaks if we find them. I haven't found that many, to be honest. I've been shipping Haskell to production for not that long, I guess. I haven't really pushed the tires on it, and that's why we're on this stream. We're gonna find out. If we hit a space leak, we'll figure it out. It'll be okay. We're not gonna burn down houses or kill babies by having a space leak. Okay. So we got the int parser, which is kind of the same thing, except we're being pretty permissive here, and we're reading an arbitrarily sized integer. Again, that kind of worries me a little bit, if only because maybe somebody could put like something stupidly large there, and then yeah, I've never really run into space leaks either all that often. I've ran into one once, and it was really easy to debug. Like, squinting hard enough at the code, found it. I didn't even have to fire up any tooling to get it. So, array parser here, same thing. We read the integer, we only parse a certain number of things out of the array. Then we put together our prim parser, which tries any one of those three things. Yeah. So we're going to move on to commands, I think. And we're going to take this sort of low-level serialized format. We're going to start building on top of this in the next layer, which is kind of what we ended up at last week. I think we ended off with that. So I don't know if there's too much else to say about this right now, other than those kind of like concerns about sizing things. Yeah. Of course, this is going to probably be, this is just byte strings, but it'll probably just be all UTF-8 type stuff. Because that has to be ASCII. Yeah, it's good enough for now. Let's not worry ourselves too much about it. Okay, so let's start a new module. We kind of ended off the stream last week with trying to write a, like, I kind of wanted a parser on top of like our prim data structure, and I don't think it took me too long to realize that maybe we don't actually need to write a parser the way I was about to start writing a parser. It doesn't make too much sense. We can actually probably just start doing this in just plain old pure code and plain old Haskell functions, which is going to be great. Rosby dot, what do I call this? Protocol? Yeah. Protocol to command. And we'll import the serialize. Serial. So I was about to go into like this whole thing of like writing functor instances for our new type parser for this. I realized it was probably going to be a lot simpler probably to do it this way, which is just to have a from prim function like this, which takes, excuse me, a prim and returns a command. I'm going to have to determine what that is. I don't want to import distribution symbol.command. No, thank you. Nice suggestion, but we're going to define command now. And our command's going to be like just the more semantic things that a user is going to want to do with our server, which is probably set a key and get a key, and probably delete a key. That's completely not the right syntax. We'll derive an equal and show instance for this data structure. Yep. That one. And we'll import the rest. Well, we'll see if we need to import qualified. Okay, and then we have to define a type for key. That's going to be our wrapper around keys. So we're not just calling keys byte strings. We're actually going to give them a data structure and some meaning to our program. And maybe it'll look kind of like this. Yeah. I don't know if we need to derive anything for that right now, except maybe show. Maybe echo show. Why not? All right. So that's the basic what we're going to start with, and we can go from a pretty like a pure function over prims to commands, I think, pretty easily. It shouldn't be too hard. Now our protocol is going to follow some of the same ideas as the Redis protocol, as we're parsing these primitives into commands. When the user sends us data in our protocol, they're going to send us data serialized in a prim array. And then we're going to interpret basically that prim array into our command type, set, get, delete. And hopefully that will be pretty good. Right, so let's go from prim. First of all, we're only going to handle arrays. So I don't know if we really care about the array size right now, but we got the prims. We're going to put something there. I'm going to fill in the other ones because I don't really care what the other ones are at this point. Which reminds me that we should probably have something here because we're going to go from a prim to a command. There's a possibility that you're going to send us the wrong thing, and so we're going to deserialize prims as not an array, but we still have to handle the string case and the int case. So this should have some kind of failure mode. We'll fix that later. It shouldn't be a string. What's a prim? A primitive. Maybe we should just call it the full name, primitive. That's kind of the name I got. I don't really know what a good name for it should be, so maybe let's just call it primitive. They're just the bits and bobs that make up the serialization format. Here. You don't want to form that properly. Okay, cool. And that's in our serial module there, so we're just layering on top of this. So from a primitive, we probably need to update all of these. Okay, good. Cool. No errors in this module. Cool. I'm just going to go commit that quickly now that we renamed that. Why not? I don't know why that's what that is. Okay. So modify serial. Shout out to Wizard Stick in the commit history. S term for serialization term. Shop smart. Shop S smart. Yeah, that's also a good name too. I like that. It's an Army of Darkness reference, I know. Hopefully most people understand that one, but if you do, we shall be super good friends. Right, so let's get back to command. Right, so primitive to either string or command. Primitive coming from the serialization module, so should be pretty straightforward. All right, so if we don't have an array when we're trying to parse this stuff, then what are you doing? That's not right. How dare you? We should probably return a sensible error. Again, we'll probably refactor this, but just for expedience's sake, we'll just make it a string for now. This is a terrible error message. Don't write error messages like this. Don't. Just be kind to your users. Think about your error strategy. Yeah, either is pretty good stuff. Yeah, so that leaves us with just this case to handle. Okay, so if we have an array of primitives, the first thing we need to do is take off the first element in those primitives and inspect it. see if it matches what we need that thing to be. So it's got to be a string, for one. And it's got to be the right string. And there's a case in here where prims, because we defined it as a list, could also be empty, which would also be quite wrong. So we might as well just handle that here. Again, super great error messaging. And otherwise, okay, cool. Let's take, now we know we have at least one element. And some others. So let's match on that. It's got to be a string. Number maybe, the length. And the bytes. Let's see. Not liking how this is turning out already. Because we also have to match on the bytes here as well. Let's just kind of see if this works. Right? This will correspond to our set command, get command, and maybe we'll call it del for delete. They're all 3 letters. Why shouldn't they all be 3 letters? That totally makes sense. Very rational. Super pragmatic. Not academic at all. Okay, got a couple of holes here to fill in. So we match that with p's, and we need to match the rest of the prims to fill in our set command up here. How are we going to do that? Let's see how. Well, we need to construct a key. And this is where we might have an opportunity to create like kind of a smart constructor for our key and throw an error if we can't get one. So we don't want to consume the next element in our list unless we can parse the key first. Because if we don't parse the proper key, then why should we parse the rest of the stream? Throw that error. Raise that, create that space leak. Okay, so let's try this with set. How do we do set? Okay, set. Let's pull out the first element from p's. Oh, well, we have the case where p's could be empty. Another case statement, why not? Potentially a key. Or we have the element of just a key. Or just something. We don't really care. We actually want. Yeah. Okay, let's do it this way. Let's just see how this rolls out off the tongue, so to speak. Okay, so we have a key here. That's cool. Those are really the only 2 cases we need to handle here, but I'm feeling we're going to get into a bit of a pyramid of doom here. So if we have a key though, this should be a string of of keylen let's give an arbitrary number, 512 bytes, just to see what it looks like. If it's greater than left, too big saw. Else, now we can construct a key. And then we gotta go recurse again. So let's try this out. Actually, we just need the rest of P, the next element of P's. So let's do this. Sorry, not string. We're working on set. Key is key. And the next element should be I think there's like a data.list. Something there for me. Search stackage. Or maybe even Google. That don't even tell me. But it's in data.list. And head is unsafe because it could be empty since we're parsing. What do I want here? I want like head may, you know? Why do you gotta give me a partial? We don't know that it's not an empty, so we can't use that. Oh, what is the thing I'm looking for? You'd think I know this stuff by like off my heart, but I swear I do. It's just streaming. Sometimes your brain doesn't work the same way. Indexing, no. All right, whatever. What we're gonna do? What are we gonna do? We're going to I don't want to pattern match again. Too few. Okay, now we definitely have the data. Anything else we don't really care about. Okay. Now we can finally flesh out end of the data. Oh, sorry, of course. And otherwise, We have another case as well. It could not be a string at the top. It could be a number or something else we're not expecting. Okay, it's messy. It's messy, but it works. Basically, when you have a mess like this, it makes me want to use something that hides all of this plumbing. I'm thinking that we should probably get some monad action going on here or something. You know what I'm saying? Because all we're doing is we're just going down that list, trying to pull things out. So let's pull out some of this stuff into smaller functions and then try to compose it back together. So let's get parse set. And that's going to take an array of primitives and give us back a command. Cool. Cool, 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 cool. So if you give us the empty array, way too few. If you only give us one element, still not enough. If you give us, you basically have to give us, what is it, the key and data and whatever else. We're not even going to touch it. That's the right recipe. Sorry, this should be either. Right. And Z. Oh, sorry. Y and Z. Oh, yes, but what's the error, friend? I don't care about that one. I don't care about that one. Oh, right, because these are still prims. Of course. Quick and dirty. That's looking a little bit more sensible. We still have one more case here for basically anything else. And if we try this out in the RAPL, maybe we'll see how it goes. Yes, yes, yes. I don't care about the type holes as long as... Okay, that's fine. Okay, let's replace the type holes with just undefined for now so that we can move past that. Where are they? Yeah. Hey. Yeah. Redundant. Got it. We'll fix that. Because we'll run hlint before we commit the code. Getting smart. Okay. Right. So let's try parsing a set from primitives. So we got string reset. This will be the happy path. String, I don't know, key foo, and the fooist. The fooist. It's not in scope. Why not? You should import all my things. Rosby.protocol.serial. Let's just start that all over again. Probably because I didn't pick up my modules after those errors. That's better. Right, so we got the set there, the set command. And if we tried, like we messed this up, that's about what we expected. What error did we wanted to get? So there's kind of those three cases there. Oh, we got the hoo-ha one because we could match on the string, the exact string set. We should get way too few if we don't give enough items. We still get a hoo-ha. What if we give it a num? Still get hoo-ha. So, not very descriptive of the problems here. Because... And if we give it the empty list, will it actually match with the first one? It should, I guess. Yeah, that one matches. So the single element case isn't matching. That's okay, I guess. And the other one's okay. Way too few. Hoo-ha, and good to go. So I kind of feel like that's pretty decent. It's still not that clean. Let's write it again, but for parseInt, and see what happens there. See, we're getting some redundancy already. Or it should be like none, I think. And wait, we're not parsing. Yeah. Oh, no, not parse now. What am I talking about? Get. Right? Yeah. Okay, the key. We don't need anything else. Just Y. That should be good enough for that. And parse delete. Yeah. Right, we're starting to see redundancy a little bit here. It's not the worst thing to have a little bit, but there you are. Okay. Oh, we actually typed it as delete. Okay. Well, that looks, I mean, that's better than that. So I'm happier with that. If we keep with the pattern match here that we pull out from here, we can actually remove this part. And replace this whole monstrosity. And we give it peace. And same thing with get. And okay, not bad. What do we think? I gotta stay hydrated. Talking to yourself while you're coding, or talking to you while I'm coding, and trying to keep things interesting. Whew, takes it right out of you. Stay hydrated. Also, it's just good for you. Right. So, we got this kind of okay-ish looking code for parsing get, set, and delete from our serialization format. Kind of works. Always a little bit wary of these string things. Cool, 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 cool. Oh, that's the wrong constructor. Should be delete, delete. That's right. Get, set. Yeah, oh, Did... Oh, because I'm still parsing sets. Sorry, that's my helper function. So we should probably not... I mean, I don't know. I don't know if you've noticed, but I'm not a huge stickler for export lists or import lists. I know a lot of people, it's kind of like editor wars type conversation, but what do you think about export lists? Do you use them? Do you avoid them? Do you recommend them? Do you not care like me? I'm fine with either. Where I work on code bases that have them, I use them. But for my own stuff, I don't tend to. But maybe that's the Python programmer in me. I spend a lot of time being a Python programmer, and I just export everything. Not much of a C++ programmer. Well, I mean, I write a fair bit of C++, but I don't know. Export lists. Why are we getting that? It's because we're trying to use parse set. So if we do this with from prim, that's the one that should do it properly. And dispatch to the appropriate parser. So we do it like this, from prim. Stir 3. Stir 2. 3 to foo. Oh, it actually wanted an actual type of primitive, which is going to be our array of 2 elements. Must be in array format. Something's wrong with from prim. Oh, yes, we're hitting the first match case. Way too soon. That should be our fall through, so last. And non-exhaustive patterns. And that's because we're patching on string, but nothing else is the first element. I thought that case would catch on it, but I guess we got to be a little bit more explicit here. Try that. Still not exhaustive. What are we missing? Usually it gives you like a nice little, oh, parse delete. These probably all have them, yeah. The hoo-ha. Forgot the hoo-ha. Oops. Delete. Can't forget the hoo-ha. That's just wrong. Gives you non-exhaustive pattern match warnings. We got the hoo-ha. Why did we get hoo-ha? Ah, because I forgot to remove this part of our pattern match. Here. I might as well do that for this one. Try that again. Now we should be good, right? There we go. All right, ship it to production. We're done. We're not done. We're a long way from done, but that's okay. We're a long way from the start too. Okay, delete foo works. Get foo doesn't work because we do this. Right. We have another unexhaustive patterns case, so this is probably a good time for us to automate a bit of this. Maybe we should do some quick check testing. Because you and I both know that we're going to use this library correctly and hook things up properly. We need a fall through case here. Basically the same as the other one. But yeah, a quick check tester would probably go a long way to automate checking that for us. And getting all the edge cases out and shaking them all out. Smoking them out. That should be area hoo-ha. Yeah. Good. Okay. Let's do some quick checking on this. And maybe clean up this code a little bit. We'll get some quick check tests going first, and then we'll refactor once we smoke it all out. I mean, it's not the greatest, but it looks okay. We can refactor that later. Hey, IsoVector, welcome back. Thanks for coming again. We're just on the second part of the stream of working on the next layer. Just parsing our data structures we got from deserializing off the wire to actual commands. So we're doing good. We're going to take a break and start writing some quick check tests for this module here. And hopefully we caught all the edge cases already, but it'll just make us sure of that. Yeah. And then we'll probably want to be able to add onto that by having the error case for when we're parsing, say, the set command, and we get a key that's too large for us and things like that. So we really want to parse this list of primitives, this array of primitives, into a valid command. And we don't want to be passing around invalid data after we're done parsing. So let's parse, don't validate, folks. Tell your friends. All right, so let's look at the test module. This is, we haven't opened this up yet. This was kind of generated for us by, all the way at the beginning by our handy dandy stack template. So it doesn't really do anything yet. And we can just run it. I think just stack test. So we're going to go ahead and fix that. There's some handy dandy ways of structuring tests. I won't spend too much time on it. We'll just get it going. So the library we're going to need is quick check. Sorry, running Rosby. We'll add that down here to our tests target. Quick check. And probably HSpec. Seems reasonable. Okay. Oh, it's probably not finding it just yet because we haven't downloaded it yet. We should probably also switch the stackage. Nightly now has GHC 810 in it, which will allow us to use the nightly snapshot with all the libraries that are tested against it instead of using our, I don't know, like 8.8 snapshot with our GHC 810 compiler. Just working so far, but kind of the jankster. Yeah, things are going good, gotta say. I'm happy with this WSL2 environment for compiling our project in. It's a fair bit faster. I'm looking forward to moving on from the parsing stuff. Hopefully tonight we'll get to hooking this up to our socket handler, and so we can start parsing commands over the socket. But after that, I think we'll probably end up getting into the meat of it, which is the storage backend. I've been doing a fair bit of research on that one. I'm kind of slightly nervous about doing it on stream because it's a little bit outside my comfort zone. Not super far, but it's not something I've really done before. So I'm learning a lot, and it's a lot of fun. Kind of want to work on it all the time if I can, but you know how these things are. And so it'll be kind of neat to see it on the stream, I think, too. Being able to sort of see if Haskell can help us with the design of our storage backend, because a lot of people say, you know, Haskell really helps you with the design of your programs. Let's see, quick check needed, but the stack configuration has no specified version. It's with capitals, yeah. I always mess that up. Because I don't like rate my dependencies very often, so I always forget. Yeah, upcase. Yeah, and you. Upcase word. No, not the whole. Never mind. Sometimes Emacs doesn't know what I'm thinking, and I have to do things manually. Ugh. It's not the only. I think the library we wrote might have capitals in it, maybe. I think there are others, so we're not alone, but it's not usual. I like lowercase better myself. Okay, so it's fine. It's actually building this time, which is a good sign. So look how much faster this is. I don't know if you've watched some of the stream before, but compiling on native Windows for some reason is just slower, but compiling in a VM in Linux. I don't know, maybe it's just me and the shiny. It's just getting to me. Okay, so quick check. We're going to run an hspec. The documentation for that, let's just pull that up. Oh yeah, I'm going to be doing the storage backend stuff on stream for sure. And we might end up doing a little bit of formal methods on the stream as well, just because I'm not too 100% sure about how we're going to end up designing the B+ tree to be concurrent and safe. So when I'm not too sure about things, I like to kind of slow down a little bit and use math to check myself. But we'll probably start with a naive implementation, like one that just blocks the whole thing. And yes, please, algebra-driven design. Just start a stream, my friend. Tell us. I'd love to hear all about it. Yeah, so quick check. This is... sorry, hspec is the test runner that we're going to use. I'm just pulling up like you run it in a spec. The spec has, what's the runner called again? Run.io? No, that's while constructing the spec tree. Oh, it's just hspec. That makes sense. Right. I don't know, describe something. So we're going to describe the command module and Bob's your uncle. It does something. That might be unnecessarily many do's. Let's just make sure we're actually got this set up properly. Yeah, so I don't know. Designing the parallel part of the parallel data structure is going to be pretty interesting to see how far we can push the concurrency primitives, the concurrent library, and see how we can get that going. And also the other tricky part might be the streaming the data so that we don't overload the RTS and try to like evaluate the entire 2 GB byte string that the user is trying to upload and then copy that. That would be bad. What's this going on? SQLite 3. That's weird. I didn't ask you to do anything with SQLite 3. Rebuild. Yeah, we might model it out in TLA plus or something to that effect. I don't know if we want to go full theorem prover mode and just go galaxy brain on it. It depends how unsure I am about the design and stuff like that. So right now in the background, I'm just doing a little bit of research. You know, what data structures do I need to support? Looking in the literature on B+ trees seems to be the way to go if we're going to go with like a page-based allocator, because we want, remember, part of our design is we want this like fixed pool to allocate into, and we don't want to go outside the size of that pool. So having our B+ tree be kind of the index into our pool, and the leaves hold the pages, then we can hopefully have a nice structure there. Okay, we got a failure. That's about what we expected. So the tests actually run. Cool, cool, cool. Alrighty. So the other part of this will be getting a quick check going up. Handy shortcut for that. We can just write these as props instead of like whatever. But we don't have a property to test yet, and we need arbitraries to generate data for us to test with. So here's one thing I don't know how people kind of do that, is where do you put your arbitraries? Do you litter them in the modules with your types? Do you put them in other modules? In the testing folder, perhaps? Or do you have like a test submodule in here that imports the types and has the instances for your arbitraries there? Decisions. But anyways, let's try and just write it in our test module and see if we can do it without having to litter our command module with test stuff. So to write an arbitrary in quick check, I was just doing this all afternoon in JavaScript too, which is super fun. But quick check is just so useful that if you're in any language, you probably have a library for it, and it's useful. It's good to do. It's good to use, I find. If you look at studies on code review and some of the conclusions they read there, they say like for informal code review, you really only should be reviewing like 200 or 300 lines every few hours of code. Any more than that, it's just too much cognitive overhead. And sometimes you get like these pull requests with 700 lines of test code. And you have to read all that test code to get into it. Generate your tests. It's so much nicer. Yeah, so isovector puts his in the same module. And isovector, I think I might agree. So I might end up doing that. Right, so arbitraries. Ah, there you are. Anyways, class arbitrary, that's the one we want. So we just have to provide, I think, the minimum definition. We just need the arbitrary for that. So why don't we take isovector's advice and just do that right in the command module. I assume that's what we're going for here, so. Put a little hole in it. we don't have that yet. Couldn't find that. Man. No good, GHCIDE. No good. Let me just compile it for you. Okay, so for our I was thinking for our testing here, what we need, we're trying to test from prim. So we really should have actually an arbitrary for our primitive types. And specifically, we only want to create instances of, let me just back out of that, the array ones, because those are the other ones we're parsing. Everything else is just an error. So if we go back over to serial, I'm going to do that here. Of primitive. What did we do? Oh, I actually have to make it a dependency of our library in order to do that. I don't know if I like that. I don't know if I like it a lot, because we don't really depend on it for functionality, do we? Anyway, let's just go ahead and do it for now. If we think of a better way of doing it, I'm all ears. Oh, no, it's capitals. Watch yourself. Oh, IdentityGS. Thanks for the follow, buddy. Fellow friend and Haskell lover. I'm a little late on catching that, but it's much appreciated. Okay. No, we were in serial doing this. Where are we at code-wise? It's been a while since I checked. Yeah, okay, we're still fresh. Okay, cool. So arbitrary. In here, we need to create an arbitrary primitive. And we've got some type here with 3 different constructors. And I want to make sure that we can also, and quick check probably has something to do this, where we can pull out an arbitrary constraint to just the array types. So my thinking here is that we want to generate, really we're only interested, I think, in, it only parses, we only get, I don't know, there's like a couple of code paths there. I just want to focus on the interesting ones, really. As I don't want to spend too much time testing all the obviously wrong ones. But for from prim, we can only pull out arrays. We can only parse arrays. So it makes sense for us to be able to pull out an arbitrary that is an arbitrary primitive that is only from this constructor, which I don't know how to do exactly. So let's look at up sized tree. Looks kind of like what we want. Right, because when we're generating value, the generator takes some size as input. That's cool. So that's kind of flare of a recursive type as well, isn't it? Which is what we kind of have. So we can generate arbitrary sized trees. Co-arbitrary. What is that all about? Different values are interpreted as independent generator transformers. Interesting. You know, nobody writes Haskell like this anymore. I don't know. I don't see enough people writing Haskell. So if you're inspired, I encourage you, start a stream. Show us your Haskell. I want to know. Yeah, okay. So variant. I think co-arbitrary looks like it kind of gives us some type as the first argument. And then we give it another. Let's see if that works. Choosing between alternatives. Yeah. Guess test case. No, that's not what I want there. But yeah, I want to be able to generate one arbitrary thing of my sum type, basically. So let's try that. Consume the thing. Yeah. One of is probably it. Do they have a search function in here? They probably have it in here. Google. See, sometimes Google just knows. Okay, yeah. I like that. Okay, and we can choose frequency as well. It could help us give us distribution over which ones we should choose more often than others. That's cool. Yeah, these are all really handy, the generator combinators. And that's totally what I was looking for. Thank you, ISO. Yeah. So one of, I'm going to pull that over to the left a little bit. And basically we can generate an arbitrary string number or array. Now the string takes a size, and it must, the size technically in order to be constructed properly has to be the actual size of the byte string. Ugh. I wonder if we can use do syntax in here. Size is arbitrary int. Hopefully that works. And can I get a sized byte string generator? Resize generators for particular types. There we go. Bounded enum, Unicode, ASCII, printable. No. Byte string. did not like my byte string. Vector of word 8 would be fine too. Would that be a... We'd have to convert that to a byte string, I think. List of A. List of word 8. But that should be good. And stir. Vector of, what does it take? A size, that's good. And an element, a gen of A. So we can get cars, which we'd have to convert to word 8s. But if we stick to ASCII car, that should be good. Arbitrary ASCII car. That's the one. And the type of that string, okay, so we're going to need to import, oh, we have that probably already. Byte string is B. B dot pack. Don't know if type checker is going to like you. It wants a gen of primitive, not an actual type primitive. Do we have a constructor for gen in here? Generate. It runs one. Okay, well this looks like how we make them. One of nope. Sized. Actually, size might be pretty all right. Yeah. Gen is a monad, my dude. Yeah. Says it right there. Cool. All right, so then we should just skadoosh. Now pack isn't going to like that because that should be a word 8. There is, I think in word 8, a function for that. We have that imported. I think it has E8. B8.pack, yeah. Okay, cool. Got that one down. Next is num, which is going to be pretty easy because it's not size, it's just any integer. So we should just be able to do arbitrary. Oh, sorry, not int. It needs an actual integer, not a type of gen. So let's just run one. Sloppy but good. And finally, our array type. This is going to be an arbitrary sized array of some doohickeys. I love stylistic suggestions from the Peanut Gallery. This is multiplayer pair programming, so totally cool. If you're not terribly experienced, don't be afraid to pipe up and ask questions. I'm happy to do my best to try and explain things. And if you are someone experienced and you see someone asking a question in chat, be a friend. Answer a question. It's totally cool. We're learning here, and we're learning how to build a database. This is something I haven't really done before, at least especially in Haskell. So we're really kicking the tires and trying to have some fun with this and learn some stuff. So questions are good, and stylistic suggestions are also good, because who likes to sit here watch me go when you know the answer? I know how frustrating that is sometimes watching YouTube videos and being like, oh, you missed the thing. Right, so we got our first one here. This is going to be a good one. String into one of string size with b.pack apply fmapped over vector of size. Okay, that's not so bad either, right? Something like that, but can't quite read the formatting in the stream very well here. Oh, right, size takes size. And arbitrary like that. You know what? I'm going to keep that in my pocket, and I'm going to finish up our thought here on array, and then maybe we'll do a second pass on this and clean this up. So arrays also sized as well, and then we just need an arbitrary primitive of our type. So hopefully we should be able to do something like this. And oh, I think I see the suggestion now. Yeah. A vector of arbitrary primitives. Ooh. Yeah. Oof. Oh, what have I done? Nope. Let's just do it our quick and dirty way, and then we'll fix it. Super recursive, super self-referential. Might not even let us do this. No. That's because that should be up here. Now you're happy-ish. Okay. Okay. Super good. All right, so we got that out of the way. Yeah, let's clean this up now and take isovector's advice here. So he's suggesting that we could remove this idea that we have here where we're kind of binding all these things and then constructing them and then passing them off to pure. That we just use the functor over vector of, because that returns a gen and a gen is a functor. Then we can kind of minimize some of this stuff. So let's go ahead and work on that. And so we got the string size, compose with b8.pack, and then we just inline the fmap what we get from stir. Pop, pop, pop. And then we can get rid of that. It's an equivalent expression. Hooray! We could do the same thing for num. Although that gets rid of that. And bam, one more. That gets rid of that. So we just generate the size of the string and the array size. Can we go further with that? That's pretty good. Yeah, and then we can only generate the size once. That's a good point, because it's kind of the same thing. So let's go ahead and do that. And you as well. Great, cool. I like it. I like it a lot. Let's move type applications out into our module though before, our packaged YAML before we go ahead and commit this. This will probably use type applications a fair bit. And I don't like language pragmas at the top of files. It's just a different day and age, folks. And when I started picking up Haskell and really getting into it, I was reading code with all of these almost all the time anyway. So you just got to get used to it. It's just the language now as far as I'm concerned. There is a Haskell 2020, just nobody's formalizing it. Right, so I'm moving a little bit fast again and not thinking this through. One of the things, oh, apparently LSP can't pick up on that. One of the things we need to think about too is that arbitrary integers, like I was saying when we were first generating this arbitrary, is that the a correctly parsed size is going to be non-negative because we check for that in the parser, but constructing it here in the arbitrary, we need to be careful of that as well. We're generating the same thing that we would actually expect to get when we're testing with modules that use primitive. So I'm going to restart that there and hopefully that goes away. So we need not an arbitrary int. We could use an arbitrary natural number, which I think I saw one for that. Sized integral, sized natural. All right. And that way we don't also generate arbitrarily huge strings and stuff for our tests. So let's use arbitrary sized natural. There we go. And it takes an integral A constraint. So a size parameter. How do we give it the size parameter? It's cool, but sometimes there's hidden comments in the source. Yeah, it is a oh, it does take a parameter. Okay. Yeah. It's passed in by the generator. Yeah, so that's cool. So that'll pick a natural number. Now, is there a combinator that we could bound so that we choose it within a certain range? Say natural number less than 800. Sized. Takes a function from int to gen A. Gives us a gen A. That might be it. Oh, and maybe we don't have to define that. Okay, well, let's leave it for now. So that takes care of negative numbers. We get only positive numbers. We'll have to be careful when we're running our tests that we specify the size of the primitive we want. That's good. Okay. So let's commit that. Let's just review what we have. So we added type applications as a default. Yeah, we're working in serial, so that's all the stuff we just added there. Don't think we need to add that yet, so we'll just commit these things first. And Bob's your uncle. So we kind of moved a little bit more carefully here to go into testing this command module, which is a good thing, ultimately in the long run. I feel pretty good about that. But it might mean that we don't I probably won't have time to start hooking this parser up to our socket handler. So we might have to circle back on that once we feel good about this command module. So we added the arbitrary instance for primitive. That's good. Now we can get back to our test. So this is where we need to think about how we're going to generate our arbitrary array and pass it to from prim, which it might be a better name for that as well. I mean, it is in the command module, so there's the context there. Command.from primitive. Yeah. So instead of it, we can just do prop, I believe. And then we have our property in here. What property should we test first? What makes sense? Right, we want to really generate arrays of a certain shape, which are arrays that have a stir as the first element of one of the commands that we have, at least. And then we probably want to have a property that tests to make sure that, like, any nonsensical primitive to from prim just results in a left. And I think that'd probably be just enough, I think, to make me feel like we're going to catch unhandled patterns or and maybe we can also have a property to specify that, you know, we handle keys of a certain size as well, because we have that kind of requirement too. So there's probably a few here. Let's think about the easiest one. It's the lowest hanging fruit here. Something to do with erroring out on nonsensical stuff. Right. Yeah, test your generator. Okay, so let's, how do we get our generator here? We gotta basically, well, I kind of like how we're doing it in there. We want to get some primitive. Right. And now, something about our primitive that's interesting. Is it equal to itself? It doesn't have an equal instance. I don't know. Let's just make sure that the code actually like runs. Hopefully it'll give us an error and we can just bounce off that. It's how we do sometimes. When you don't know, just compile the code and let it go. Jesus don't care if you make a mistake and you compile something that doesn't make sense. Right, okay, well that's not in scope, so that's not going to work, of course. Try that on for size. Yeah, we probably got something else done. Prop. Did I mess that up? Take care, ISO Vector. It was good hanging out with you. Thanks for the advice, and happy trails. Hope to see you next time. Maybe I got a different version of quick check, yeah. Maybe. Or no, it was under test hspect. Yeah. Oh, I probably got to import that straight from this model. Test.hspect, quick check. That's probably what it is. Why, oh why, GHC IDE, are you not running here? There we go. Well, we're getting somewhere. All right. Okay, cool. So it's not the type I thought it was. I thought this would generate an arbitrary primitive for us to test equality on. We're getting a gen of something. Haskell doesn't know what. So let me just check the quick check documentation, make sure that that's the function I need to be, if I need to call something on it to make it come alive. Hydrate, good call. Looking out for me, fam. Voice is getting a little dry. Oh, so much better. Ah. Okay, yeah, let's get that data. Oh, we can do, oh, that's debugging generators. We can sample it a little bit. That's cool. Why don't we try that? So let's import test.quickcheck here, and then we should have the sample function. Right. Oh, there you go. Super hostile input. And zoo, this is what we're talking about with size here too. This probably picked like a huge number. So we probably want resize. So we have something a little bit more that we can sample more usefully. Say like, I don't know, 3. That's better. So this looks pretty good. An array of 0 length. Array 2. Ah, here's something. It's generating arrays of arrays, which our parser won't generate from a string, from a byte string. So, because I don't think we're going to really handle. I don't even know what in Redis uses arrays of arrays. I don't want to have to get in the whole mess of trying to figure out how deep we're recursing and put like a limit on that. if we don't even need it. So we should probably take care of that when we're generating arrays. We don't want to generate arbitrary, we want to generate one-ofs. Or maybe such that's. That looks good. String 2. Yeah, I think that's right. That looks good. Yeah, narrate arrays again. Okay, so we have some work to do a little bit on our generator of our arbitraries. Okay, so we don't want just any arbitrary primitive when we're building arrays, because that's not what our parser will give us. So let's think of how we can constrain this so that we only get arbitrary of the specific kind, or type that we want from the specific constructor. And I think that might be from no, well, it could be one of. Don't have an enum A on our thing. We could use maybe such that. Yeah, let's try such that. So we basically give it a predicate, and we'll use the predicate, which will be our type, to match on whether it's the ones we want or the ones we don't, and ignore the ones we don't. And our predicate here will be lambda case. Where we have the formatting of this is getting too far to the right. Right, where we have stir anything. True. We have none, anything. That's just one. Also true. Otherwise, nope. Not the best formatting, but that's okay. All right, it's looking a bit better. No arrays of arrays. All right, and I think I thought of just a property we could test our generator with, if we wanted to do that, just to get us going here, is just to make sure that, like when we have an array, that this field here is actually the length of the list here. For the string type, same. And the number type we can just, we don't really care about. It's just the number type, it's trivial. Cool. Let's just get HLint on that quickly, and then we might have to top it off there actually. What happened? Oh, okay, because I'm running in Linux now. It hasn't built it for this environment yet. That's no big issue. I guess we could just do this. No hints. Are you sure? It seems to like our crazy fun times. Happy fun times here. I'm just going to break that out just to clean it, because I just don't like it. It's just not nice. Only oyster. And go back up to that case. Put you there. Oh, no. It's having a hard time lining things up because there you go. And we'll clean that up there too. Just make it nicer to read. Okay. Oh, do we still have a parse error? What did I do? It's probably just a vestige. Okay, that's probably a little nicer. Still no hints. Okay, cool. We're good there. So let's create that commit. Good thing we didn't push. I don't think we pushed that yet, so we can rebase this and just make it look a little nicer. Array values. Our parser would output. Yeah. Okay, let's just do a quick review. Okay, that's... Oh, we just renamed to prim. Okay, that's fine. What happened here? Rebase these two. Oh, sorry, I've got, yeah. What's this? Oh, we haven't even added that file yet. Okay, let's stash those changes for now. We will now do the rebase. Just to squash those two together. I think that makes more sense. Okay, and then we'll add the command module that we wrote. So yeah, this module deserialized and constructs and objects. Sound fancy. Cool. That's a fair bit of work. That's all right. Thanks for tuning in, everybody. Next week, I guess we'll continue on with the testing story if I don't get ahead of that between sessions, and then we'll get this hooked up to the socket handler, and we'll see it parsing off the socket, and we'll echo back maybe the show instance of our command types, and then we'll start getting into the storage backend probably, and all that stuff. We'll probably talk along the way about laziness and streaming and all that kind of stuff as well. Thanks again for tuning in, and if you like what you saw, give us a follow. It'll help you know when the next stream's coming up and keep up with it. If you have friends who'd be interested in some of this content, I do back up my stream to YouTube, so you can like and subscribe there, share the videos, and gosh, what else? I don't know. Have fun. Hack some Haskell and share your projects as well. You can find me on Twitter at Agent Ultra, or you can find me as well on the functional programming Slack, on the Zulip server, as well as on Reddit. So thanks again, friends, and we'll see you next week.